Okay, well, the amp is complete, except for the top cover. And before we do the testing, one thing I like to do is turn it over and give it a good shake. You know, if there's anything loose in there, wires, solder, anything that could possibly bounce around and cause a short. I didn't see anything fall out. And now it's time, I guess you could call it the moment of truth. So, referring directly to the manual, now that we're complete, we have to perform a couple of real quick and easy tests. And the first one's called power off tests. And we connect an ohm meter to the left and right channels. All right. And we should look for 900, somewhere between 900 and 1,000 ohms. And there's 999. So that's 1,000. That's 1K. And now we're on the left channel, and that's 999. That's good. All right. Disconnect the ohm meter and set it to DC volts. Set that right there. Oh, well, I guess I'm going to have to plug it in for this one, okay. And I don't know where the power cord is. Oh, isn't that great? I've got everything here but the power cord. Alright, well, I guess I'm going to go find that. Okay, so I have the power cord. It is not plugged into the wall yet. Just going to go ahead and plug that in, make sure the switch is on the front is off. I'm just reading the directions. Okay. Apply power to the amp. So plugging it in and turning it on. Looking for smoke or sparks. I just heard the relays click. That's the first. Let's do that again. Okay, relays clicked off. Okay, let's listen for the relays again. Okay, I heard 2 clicks. I guess one for each relay. They're slightly offset from each other in time. Alright, the green LEDs, and there are 2 green LEDs. And they are, I have to remove this from the tripod, they are on. So, looking for something that's an insulator here. Well, anyway, there's one green LED there and one over there, and they're both glowing. And that's a good sign, and so far no smoke. I don't smell anything. I don't hear anything. No zaps. Okay. Measure the DC voltage between the red and the black speaker binding posts. Okay, I'm set to DC, and I'm on the right channel, and I got nothing. It's like 0.0005. And I'm on the left channel now, and I actually get a voltage, 0.123. And it says, you may see as much as 1 volt. That's leakage current from the capacitor. And it goes away in time or something like that. I'm not worried about that. But I wonder why I see nothing on the right channel. I mean, it's basically, such a low DC. How come one channel's got a little bit of DC, which it's supposed to have, and the other channel has nothing? You would think they'd be roughly similar since the circuitry is identical. That kind of bothers me a little bit, but I'll go ahead and turn it off. Relays clicked. And now they want you to hook it up to some speakers and give it a listen. However, install the top. Don't block the ventilation holes, give it a listen. However, I'm not content with that. I'm going to actually bench test it first with some dummy loads, and I know that these capacitors hold a voltage for quite some time. Or I should say the power supply cap. Now this thing is off and unplugged, but I'm going to get a look. No, it drained pretty quickly this time. Alright. Six volts left going down, so okay. Let me just double check that again. We'll plug it in. I'm going to do something kind of dangerous here that I'm sure it's recommended not to do, but I'm doing it. I'm going to turn the amp on, and I just want to measure one more time. There are the 2 clicks. Let me go from the chassis to VCC. Okay. 72.13 volts exiting the power supply. It's volts DC. I'm going to come over to each board, each amplifier board, to make sure they're getting the VCC as well, and they are. I know they would be because the green LEDs are glowing, but just make sure it's the same identical voltage that they're getting. There's not being dropped anywhere by any issues along the way with the wires. Okay, turn it off, clicks, unplug it. And time to put a signal into it and see what we're getting out. Okay, so got my test set up here, and I'll tell you straight up, I do have a problem. One channel is not working. and that would be the one on the left, which is the right speaker, which is this amplifier module right there. Now clearly, and I want to demonstrate that to you first, but clearly they're both getting power. I already measured it, and both have their green LEDs lit. So what I'm doing is I'm inputting from my audio generator here. I'm inputting roughly 1 kilohertz into the RCAs, left and right, the same signal going into both. And that's what you see here in yellow. And it's about 360 millivolts being input. And in blue, you're seeing the output of the left channel, the one that works. And you can see it's a nice clean sine wave, and it is 2.49 volts being output, which is roughly 1 watt. Now if I switch, so the blue trace is the output. So if I switch the output, can't get a hook on that, and partly because I've got one of my 3 pairs of glasses on that doesn't allow me to see things up close. Okay, you can see we get a straight line right there. Nothing. No matter how much I turn up the volume, nothing. So one channel is definitely out. Now whatever the issue is, it's not frying anything. Nothing is zapping or frying. There's no smoke. I can tell you that the working channel, the left channel heatsink is heating up. The other heatsink of the non-working channel is also heating up, but not to the same degree. Well, that tells me that the chip is idling and probably working. But that's about all that says. So now begins the troubleshooting process. And believe it or not, I enjoy that process. So it's not any it'd be nice if this thing worked right off the bat, so I could go listen to it. But by the same token, it's just part of the process. It's part of kit building. Things go right sometimes, and other times they don't. And troubleshooting is almost, it's a mystery that needs to be solved. So, how to troubleshoot? Well, I already measured the power supply voltage, and it's getting to both amplifier modules, so the power supply is working, the green LEDs are lit. The first step in the process is double checking the boards, and I did that. I looked at both boards. You can compare them to each. I checked the capacitors, I checked the diodes. Again, over and over again, I've thoroughly checked the underside of these boards for solder bridges and cold solder joints and missing solder joints and everything. I've done that multiple times, and I'm highly confident that the boards are assembled correctly. Check the transistors, make sure the right ones are in the right sockets and everything. Certainly I could have missed something, but I've checked it so many times I seriously doubt it. So I think we'll begin the troubleshooting process. And this is where the schematics come in handy. I'm going to start by making sure, need one of my pairs of glasses here, by making sure that both channels are getting the input signal. So for that, I'm just going to use the probe, and I am going to start with the working channel, and there's the input line right there. I need to change the settings on my oscope. Okay, so now we're going to be looking at the blue, the blue trace. That's the probe I'm using right now, channel 2. And there's our input signal to the working channel. And now we'll double check the input signal to the non-working channel, and there it is. It's getting something. The same level signal as the working channel. Alright, so we know it's getting a signal. So now I think it's probably best to work backwards. We could work forwards and trace the signal through, but I think it's best to work backwards. So here's where here's what I just probed a second ago. Right there. And it goes through R4 and then C2, and then eventually goes to the positive non-inverting input of the op amp. And we could go from this direction forward. I don't know the pinout diagram of the op amp. I don't know where pin 3 is. I'll have to look that up, but I don't need that because I want to start from the output and work backwards. These transistors right here. Well, let's start right here at the output. Do a little probe right there. I think I already know what the answer is going to be, but here's the output of the working amplifier. Hold on, I got to turn down the volts per division. Okay, there's the working amplifier. Now let's go to the non-working amplifier right there. Nothing. Well, I think we already knew that, but that just rules out a problem with the cable, with the wire. Nothing. All right. So we have nothing there. So now it would be nice to go to this side of the relay, right there, which is on one of the sides of R10 that has the inductor in parallel. So the inductor is that blue wire that's wrapped around the capacitor. So let's find our R15, that is, R15. Now I need another pair of glasses. So I see R15. This is a live circuit, by the way, so I'm just being really careful. Only putting one hand in there, not touching anything else, although what I'm doing is kind of dangerous. There's R15 right there, and I'm going to probe one side of it on the working amplifier, and I get a signal. I'm going to probe that same side of it on the non-working amplifier, and I get a signal. And I can see the trace. Well, I don't know where that R15. I'm trying to figure out which side it is, but I'm still getting a signal nonetheless. So in other words, if it's this side of it, I'm getting a signal on both the working and the non-working, and it's the same amplitude. Let me just check the other side of R15 on both of them. That's the working, and here's the non-working channel. Same signal. Alright, well, guess what? This makes it pretty straightforward, I think. We're getting the same signal in the working and the not working channel up here at the input to the relay. That's the relay. And at the output of the relay of the non-working channel, we're getting nothing. I do hear the relays clicking. So it makes me wonder, well, is it indeed a relay problem? Is it the relay causing the problem, or is it something else in the output path? What else is in the output path? You know, if that relay is normally sitting normally closed, when it's in its off position, it's going to send a signal to this R18, and when it's in its on position, when the amp is on, it's going to go to the top of R13. Now, what could possibly go wrong here? Well, the relay might not be going to its on position. It might be continuing to send the signal to R18, and it's not switching. So we need to find R18 and see if that signal passes down to it. And that's what we're going to do next. Okay, so let's start with the working channel. And in the working channel, this relay is going to be in this position right here, which means the signal that we already know is there should be passed to the speaker load as well as to a parallel to 1K R13. So let's check R13 on both channels, and R13 is right there, and I can see there's nothing on that side of it, so that's the grounded side, and on this side there's the output signal. Okay, let's do the same for the non-working channel. Let's go to the output signal side. Nothing. Alright, so we know for the non-working side we're not getting a signal paralleled across R13. Now, if there was a short across R13, that would be a short circuit, and we wouldn't get a signal that way either. But that would probably kick in some of the protection circuitry, and that's not happening, I don't believe. So, which tells me the relay might be stuck in its normally closed position and not connecting to the speaker. So for that, we look at R18. So let's look at R18 on the working channel, and measuring one side of it, nothing. We shouldn't get anything on the working channel because it's not in the circuit. The relay is taking it out of the circuit. Nothing. Let's take a look at R18 of the non-working channel. Nothing on one side of it, and nothing on the other side of it. Well, one more time I want to go back to the input of the relay, which is a R15. Let me just double check that. So I think we're down to the point where it's the relay. So let me go back to R13 on the non-working channel, and we got a full signal. And let me see if that signal is identical to the we're looking at R15 right here. So R15 of the working channel and R15 of the non-working channel. It's the same signal, the same amplitude. So the only thing I can deduce from this is that drawing the relay, we have it normally closed, normally opened, and we're getting a signal here, but we're not getting a signal out on either side of that relay. Well, that's actually a good thing, because it's real easy to desolder a relay and put a new one in. One of the things I'll do real quick is just to give the relay some taps. Just some gentle taps, and I'll measure again on the output. Nothing. Here's the output of the working. Okay. So what's the next step? I would say the next step would be to turn the power off, remove the circuit board, and make sure that that relay is properly soldered under there. And if it is, then I'm going to desolder it and measure, because the relay is nothing but a switch. So I'm going to measure the resistance through the normally closed, and see if I get anything. If it's damaged and if I get an open circuit in the normally closed, then the relay's got a problem. So that's going to be a little bit of an endeavor. I'm going to have to disconnect the whole test setup and turn this thing on its side and get it unplugged. And got to let these capacitors discharge a little bit. So, well, if that's the case, I'll just have to email Dan and tell him I got a bad output relay and see what he thinks. But let's wait and see. Let's test that relay first. Okay, next step, I have removed not removed completely, but just unscrewed the bad amplifier module, flipped it upside down, and I've identified the relay, and that's these pins there, and there. I went ahead and pulled the schematic of the relay up from the web, found the model number. It's a Panasonic, and it's laid out just the way you see it here. The coil of the relay, which is 1.6K resistance of that coil. Then you have a common, then you have your normally closed and normally open. So first, we'll test the resistance of the coil. And I don't think I can do that with one hand. So the resistance of the coil is simply going to be the resistance from there to there. That pin to that pin. $1.5K, close enough. Okay. Now we should have zero resistance for continuity between common and normally closed. .13 ohms, that's continuity. And from normally open, it should be infinite. Okay, there's normally closed. .12, .1. Here's normally open, and it's over. So it's definitely an open circuit, the way it should be at this point. So the next step is, I know that this is a 24 volt relay. It says it right on there, 24 VEF. So I've gone ahead and gotten my power supply out. I've got 24 volts right there. I looked at the schematic to make sure this wouldn't damage anything. As far as I see, it won't. So I'm going to put 24 volts right across the coils. It can be done in circuit, and we should hear a click. And that's the relay activating. It's clicking. So the question is, and how am I going to do this with one person? I want to measure the resistance of the normally open, which should become normally closed when the relay is activated. So I'm going to try. This is going to be hard to do. Because I can't get access to anything above the circuit board. I'm going to try to get these. I need access to the probably should be doing this off camera. Okay, when I activate the relay, when you hear the click, it should go to 0 or close to 0 ohms. And it does. Well, gosh darn it. What is going on here? That relay appears to be working. So the only thing I could do is, and there shouldn't be anything wrong with this, I should be able to fire this amp up with the circuit board laying right here so I can see if the signal is reaching the common pin of the relay. Maybe there's a disconnection between the resistor I measured earlier. Either that or the relay suddenly started working because I activated it with the external 24 volts. I don't know, but I measured a signal here, so maybe there's a disconnect between here on the circuit trace or something like that and the common pin in the relay, and the only way I can know that is to take a tap to measure the signal right here while I have that circuit board flipped upside down. So I think that might be the next step. Or maybe it works now. I don't know. Maybe I should try it and see if it works now. I'll do that first. Okay, so the amp is on now. The module is flipped upside down and it didn't work. I tested it, the same scenario. So here's where I am. I'm going to the common pin of the relay. Okay, I already measured the voltage at R15 and it's perfect. The signal's perfect there, which should go right to the common pin. So I'm going to take a measurement off the common pin, which is that one right there. And I have the voltage, it's blue. So that's the blue signal you see there. Now, with the relay closed, with the normally opened in its shorted state after the amp comes on, okay, the switch should flip up here to normally open, and that normally open is this pin right here, which, as you can see, well, let's take a look at it. Got a signal. The relay's fine. Well, look at this white wire right here. This white wire is the output wire that goes, bing, right there to the speaker binding post. So that's where we weren't getting a signal. Nothing. Get out of here. I can clearly see the trace right here go from the output of the relay, where I get a signal, all the way down to the white wire, where I don't get a signal. What the hell is that? I mean, I can see the trace right there. It looks complete. I can literally see it from here to there. I've never come across anything like this before. I think what I'll do is scratch a little of the coating off and try to get to the copper underneath in that trace and trace it along the way. I cannot imagine. That should be a short circuit between there and there. There's no resistance. I mean, I just can't imagine. I'm going to scrape off a little of the coating and see if I can get a signal somewhere on that trace. Alright, now this is really strange. We're down to, I've got my continuity tester. Got it traced down to a trace. Literally a circuit trace between the output of the relay and the positive wire to the speaker binding post. And before, I wasn't getting a continuity on this little trace right here from there to there. Wasn't getting continuity, so I scraped away some of the copper from around the relay lead, and there's continuity. But if I actually touch, I'm going to touch the relay lead but not the copper, I get nothing. So in the area around on the pad, there's a disconnection between the solder pad for the relay post, for the relay lead, and the actual trace. Again, I'm touching the relay, only the relay lead, and I get no continuity, but if I touch the copper around it, I get continuity. I mean, I've seen some shit, but man, that is strange. I mean, I can't even see it. I can't see a disconnection. It's been soldered. The relay lead's been soldered. So anyway, enough of bewilderment here. What I'm going to do is continue to scrape away some of the coating to expose the copper on both sides of the relay lead, and I'm going to build a solder bridge down to it. And I think that will take care of the problem. Let me just get a measurement of resistance. I just want to know the resistance so I know in the end if I've got a good connection. So I want to know the resistance between here and over here. And I've got 0.11 ohms, which is probably the resistance of the probes. Yes, it is. And I don't want any more than that once I build the solder bridge, and that should do the trick. Alright, well, let's give that a shot, and if it works, we'll put it back together again and fire it up, and this time both channels should work. Okay, so just before I solder, I've scraped away, I've used an X-Acto knife to scrape away the coating to expose the copper. And I'm going to go ahead and build that solder bridge. I think I'm going to put a little flux, extra flux on that area to make sure it's nice and clean. And go ahead and build that bridge, and then we'll test it. Alright, so there's the solder bridge. that ugly mess right there, but it is not, it's not a cold solder joint, though it may be ugly. And we'll test continuity. We'll go ahead and test the continuity. Okay, between here and the output wire. Between here and the speaker binding post. Alright, so that solves that. Well, we don't know that anything is solved until we test this thing, but I have a sneaking suspicion that I could just put this right back in and it's going to work just fine. But I'm not going to screw down the circuit board yet. Let's see, I have a signal going to it. I need to plug in the power. I've got the dummy load hooked up. It's my dummy loads are 8 ohms. I've had that hooked up all along. We'll do a double check. Plugged in. I didn't disconnect any wires. Nothing on the amp module's touching any metal except for the heat sink. Go ahead and turn it on, but you hear 2 clicks. There were the 2 clicks, one for each relay. Before I do anything, I'm just going to observe it for smoke. Smell it for fumes, smell it for the burnt popcorn. Okay. And now, I'll put it on the O-scope because I'm going to go ahead. Oh, thank God. Okay. Oh. Oh. Good. I really wanted it to work. That was the strangest freaking problem. Okay, so the yellow trace is the input signal, and it's 161 millivolts. And let's start with the good channel, which was the left. And we're getting an nice sine wave output, and the bad channel. Look at that, same level. Nice. Both of them are the same. The damn thing's working. So I'm back to where I should have been 2 hours ago. Okay. I'm just going to look at one channel here. Actually, let's look at both. I no longer need to look at the input signal. I now want to look at both channels of the output. All right. Okay, so now you're looking at left and right channels. The input signal is was 160 millivolts, and now we're looking at 3.92 volts. On the output. And both heat sinks are heating up equally. Alright, I still need to screw in the amplifier module that I took apart. So let's give it a little bit of a stress test. Not too much stress right now. I want the thing to burn in, but right now we're at 3.3 volts output, and that's roughly 1.36 watts. So let me turn the volts per division up and crank up the input signal and see if we can find clipping. There's clipping nice equally on both channels. And let me turn it down. These resistors are 100 watt, 8 ohm, so they should be able to handle it. Let me take a look at clipping one more time. Actually, let's just look at one channel. Let me start with the left channel. There it is. Okay, there's clipping. Starts with the bottom rail and it goes right into the top. And there we are, and right before clipping we have 21.5 volts RMS. 21.5 into 8 ohms, and that's 58 watts. So 58 watts right before clipping, right on par. Let's do it to the other channel. So I'll turn off one, and we'll look at the other channel. This one I think was the bad channel before. There's clipping. Starts at the bottom, then to the top, right before clipping. 21.6 volts, same exact specification as the other channel. So they both clip identically. Both heat sinks are getting warm, but not overly warm. So the sine waves look good. Let's go ahead and haven't run a distortion measurement on this yet, but let's just compare. Now we'll just pick one channel and bear with me a second. Okay. Looking at an output. Okay, we're going to compare the input with the output. So the input signal is yellow, the output is blue. Okay, yellow is my input signal, output is the blue is what's across the speakers. We can see there's a, yeah, I mean they line up, don't they? There's no visible distortion of the amplified sine wave. So it looks pretty damn good. The other channel looked equally as good. So let's go ahead and look at, let's do both channels again and look at some frequency response. So just some crude frequency response. We'll just look at both of them, and I like to get things blurred. Let's get these all tightly wound here. Okay, so let me roll this up to a higher frequency. Okay, I got 9.4 volts RMS on the yellow, and then it goes down to 7, down to 6. So we start rolling off. Let's see. 7, 6, 5, 6, 9. Bear with me a second. I'm trying 11, 9. I'm trying to 10 kilohertz. I'm trying to get up to a higher frequency. I'm sorry. I should be more prepared than this. So I'm up to 10 kilohertz. Now I'm up to 96 kilohertz, and we still have amplitude. See, I'm up in the megahertz now, right? So it starts, so we start, it's 352K. See, the amplitude now is going up. That's 140K. And there's 109K. So we still have something, some significant amplitude at 100K. All right, both channels, same behavior, right? Let's go way up, way up. Here we are in the barely any amplitude, but there we are at 500 and something kilohertz. Okay, let's get back down to the lower end of the spectrum here. And we are at 93 hertz. Okay, let's get down lower than 93. Here's where the digital storage scope will get a little slow. We are at 12 hertz. 19 hertz, 20 hertz. And let's go down really low. It's as low as I can go. I can't get any lower on my audio generator. That's 9 hertz. So we got a nice full frequency response, undoubtedly. This thing's a champ so far. So I'm going to do a thermal stress test later where I hook it up to my a larger dummy load that I have, and run it for a while at a third power, maybe something like that, and just to make sure that the heat sinks are doing their job, and that there's no protection circuitry kicking in, that sort of thing. But so far so good. How about for our last test we do some total harmonic distortion? For that I need to rearrange my test bench just a tad bit, so I'll be right back. Okay, so let's do THD. We're starting out with the left channel. That's the signal coming out. Now again, my input signal from the audio generator has a THD of something like 0.005 or 0.01. It depends on the frequency. So I can't do any better than that. Okay. So I'm just not really testing the exact THD because I can't do any better than what my signal generator gives me. And again, I'll say it's 0.01, something I forget, I should have measured it initially, but it doesn't matter. If this amp is anywhere near 0.01 or in that ballpark, it's not adding any distortion of significance to the input signal. So we are looking at the output of the left channel, the speaker output, into an 8 ohm dummy load. I have it up set to 2.9 volts RMS AC, which is roughly 1 watt being dissipated by the 8 ohm dummy load. I have a frequency set of 1 kilohertz just for this particular test. So the THD 0.01. So it's not adding any distortion. It's doing just fine. 0.01. I can't do much better than that. So let's go ahead and bump the frequency around a little bit. Let's take it a little higher. Let's take it to about 20 kilohertz. So now we have about 20K. Voltage is about the same as it was before. THD 0.0, it's floating around a little bit, but it's hovering about down there in the 0.01, 0.02 range. Let's take a look at the there's the signal. So it's still good. Let's take her down to somewhere near 20 hertz. There's 20.6 hertz. Still about 2.9 volts. THD has definitely gone up right there. We're at about 0.1%. About 0.1%. It's bouncing around a little bit. There's the waveform. About 0.1 there, so it's significantly gone up. Not significant, not audible, but it definitely rises at lower frequencies. Let's take a look at somewhere around 100 hertz or so. There's 92, about 100 hertz. AC voltage still the same. THD 0.05, so it's gone down. So it gets a little higher at 20 hertz. So, but all in all, it's perfect. It's what it should be, and we're producing clean output waveforms. I need to go ahead and get that amplifier module bolted in, and it's time to listen. I'm satisfied. I don't need to do anything else. Measures no DC across. Well, there's no DC across the. Tell you what, let's just check for DC. For that, I'm going to go ahead and disconnect, turn off my signal generator. I don't need the Keithley anymore, and try to do this with one hand, so it's a little slower. I'm going to leave it running, and I'm going to remove the signals and keep the dummy loads on. Let's go to volts DC. Nothing. No DC. That's what it should be. No DC. So I'd say all those tests are pretty successful, and both amps are behaving normally, and we are ready to roll, man. We're ready to listen. So for the listening test, I'm going to go ahead and get this thing finished and put the cover on and screwed together. And all I can say is that was one strange problem with that trace on the circuit board. Absolutely strange. That's a new one to me. I'll let Dan know about it, but that is weirdness. But it's fixed, and it wasn't a bad component. It wasn't anything, you know, there was nothing wrong with the componentry. And I still don't know what the exact issue was, whether it might have been a circuit board issue. Clearly, the solder pad or eyelet or whatever you call it must have lifted away from the circuit board trace. That's the only thing I can figure. It lifted away somehow, and it needed to be bridged with that solder, which worked like a champ. But it works now, and it works just fine, so I'm excited. I'll put it back together and we'll do some listening tests. Thanks for watching this particular part, and I'll see you next time. Ciao.